Hello, thank you. Thank you for that welcome. It's really an honor and a pleasure to be here because I wouldn't even be on stage presenting if it wasn't for ThoughtWorks. Not just because they invited me here and paid for my flight, but because in about 2006, I saw a bunch of thought workers presenting at KubeCon London, talking about agile, talking about automated testing, talking about all these things which I'd only read about, and they were doing it on site at clients. And that really inspired me because A, we were not doing any of that stuff. And B, I decided I want to get up here and start talking about those kinds of things because it sounds kind of cool. So I owe a lot to ThoughtWorks. I even worked there briefly, but a lot of my mentors are from ThoughtWorks and they've really inspired a lot of the way I think about software and developing software. So thank you for this opportunity. Okay, I'm Trisha. I work for Gradle these days. Previously ThoughtWorks, previously JetBrains and other stuff too. Who knows about Gradle Build Tool? Okay. I'm not talking about Gradle Build Tool at all. You can forget everything about Gradle Build Tool. Gradle actually has two products. It has a second product called Develocity, which is a developer productivity tool. Now, I'm a developer advocate, which means that occasionally I'm going to do a bit of product placement and talk a bit about our product. But mostly what I like to do, one of the reasons why I moved to Gradle is to talk about developer productivity as a whole. There will be some screenshots. They will be labeled Develocity. Feel free to ignore or call our salespeople. They would love to hear from you. So, my clicker is not working. Oh, now it's going too fast. No, you're spoiling the surprise. Go back. No. Interesting. What's happening? Because this is an important slide because you have to buy my book. So over the last few years, what I did is I put a lot of the stuff that I already know. I co-authored some books about Java and IntelliJ IDEA, because really what makes me excited about technology is how tooling can make you better and more productive. And so that's kind of my whole vibe is developer productivity and how tooling can help you. If this clicker doesn't work, this is going to be a very long talk. No. Is it working? Because I didn't bring my clicker because it doesn't work. So it's probably just me. I'm going to hold it in this hand and I'm going to be like this. Okay. So talking about productivity, tests make you more productive, right? Do they? Do people, who feels like tests make them more productive? Oh, good. Not many of you. This is the right audience for this talk. So quite often, if our tests are running slowly, or if they're hard to debug, or if they're difficult to write, then it kind of leaves us with this feeling of bashing our head against the desk. And we do not feel like automated tests make us more productive. We feel like they slow us down. So if you came here to hear Trisha say it's okay not to write tests, please do not go away with that, okay? Feel free to leave the room now if that's what you're expecting me to say, because that is not what this talk is about. However, I'm not going to go into all the reasons why tests are good, because lots of people have already talked about why tests are good and we should do testing and blah, blah, blah. But what I do want to say is that Kent Beck said, testing is a Xanax for programmers. It's an anxiety-reducing technique. And this is how I feel about automated testing. Before I discovered automated testing, by the way, I've had 3 coffees and I usually talk really fast anyway, so I do apologize. But I have 122 slides to get through, so just listen really quickly, okay? So I feel like tests help me be less anxious. Before I discovered automated tests, I tended to second guess myself and think, what if I do this? And what if the user does that? And what if I do the other? But by writing those what ifs down as a series of tests, even if it's just the titles of the tests, at least I wrote down the stuff I was worried about. And then when my code passes all those tests, I know that I've considered all those edge cases, and it makes me feel warm and fluffy to see the tests go green. So testing is good and you should do more of it. However, I asked a bunch of people on Twitter and other social media networks, I will not call it X, what slows them down when they're doing testing. And what we found is a lot of people, I was expecting people to say that running tests slows them down because especially in CI, it can take quite a long time. But a lot of people said writing tests is what slows them down. And then the other thing which really excited me is unreliable test results, which is otherwise known as flaky tests, or Trisha's favorite rant topic. So we will have a 15-minute rant about flaky tests in the middle of this presentation. Please feel free to cut me off at any time. But roughly the things that slow us down fall into 3 different areas: writing tests, troubleshooting failing tests, and running tests. So those are the 3 areas that we're going to talk about in the rest of this presentation. Firstly, Writing tests takes time. Who agrees with this statement? Either, okay, good. Eventually. Yeah, I agree. That's fine. So I used to work for JetBrains, so I did a lot of stuff with the IDE. So I am going to do a demo of using your IDE to help you write tests more quickly. You won't be able to see me because I'm going to be behind this pillar. But let's make a move. Let's see if it works. I'm going to find it a bit difficult to hold this and do the demo at the same time. This is good though. This means I can probably just skip the whole demo section. Do you mind? Thanks. All right. Let us do. I really did have too much coffee and I'm now shaking. Let's zoom that up. That's still working. It did not check. No. Please add mirror. Yeah. Okay, great. Awesome. So let's assume you have some code you want to write a test for. I'm doing tests second. I do tend to prefer doing TDD, but I know that realistically lots of people write their tests afterwards. So assuming we have some code and we want to write a test for it, if we use IntelliJ's function to try and get to the test and you don't have a test already, it will suggest you create a new test. So we're going to do that. Take all of our defaults, add it to Git. That's fine. We can use Command N to create a new test method. It will automatically create the basics, which will be a compiling test method. Obviously, this is JUnit Java because I'm a Java person, but the same functions are available for different testing frameworks, different languages inside JetBrains IDEs. I don't have to sell JetBrains. They're not paying me anymore. I just happen to like their IDEs. But I don't particularly like this test method because it's not enough. So I created my own live template, and the live template creates the shape of the test the way that I want it. So I want a display name. I want it to start with should. I want given, when, and then. So should extract Twitter handle from tweet. Okay. And then it will automatically create the shape that I want, put the cursor in the right place. So given, I've got an example tweet here, which is, unwieldy and nasty. So what I'm going to do is I'm going to wrap that inside. No, I'm going to do this. Wrap it inside an editor fold. I'm going to call it example tweet. And then I'm just going to fold that away so I can't see it anymore, because this is a really nice way, particularly with test data, which often just kind of clogs up your whole test and is getting in the way. You can just put something descriptive there and fold it away. So now I'm going to say user service dot get Twitter handle from tweet. This is IntelliJ IDEA's full line code completion, which is machine learning, but it doesn't dial out of your laptop. It's local, so there's nothing scary about where it's sending your code. It's actually ruining my whole freaking demo because the whole point was to not use machine learning, but it's all local and it works perfectly. So, it's there. So we can use code completion to finish that off. We extract that into an actual handle. And then we're going to use assert equals to assert that what I want to do is, because I can never remember which is which, check what the parameter is. And I say, I want Trisha _G, actual handle. Again, the machine learning has figured out what I need to do. It's frustrating. So I'm going to run that test and it passes, which makes me deeply suspicious because I'm a suspicious type of developer. I'm going to rerun it, see that it fails for the right reason, and then make it pass. Okay. So, let's discover. Thank you. The end. Goodbye. So yes, by all means, use your IDE to generate your code. That's what it's there for. The whole point is not necessarily it's going to make you write code much faster, but it is going to do a lot of the heavy lifting for you so you don't have to think about the boring stuff. Of course, we are in 2024 and it's impossible to go to a conference without mentioning AI. So now I have to do it with AI. Sorry, I'm going to need you to do it. Hopefully this is the last time. No worries. So this time, what I'm going to use JetBrains AI Assistant. JetBrains very kindly give me an AI Assistant license for free. So other Gen AI solutions are available. It doesn't have to be the JetBrains one. However, so let's go and have a look at what I want to do. Can't remember any of my keyboard shortcuts. I want to go to this method. This class has, it already has a test, move service test. And this method is already tested, but this method is not tested. So I'm going to use Alt-Enter. I'm going to use the AI actions. and I'm going to generate unit tests. Now, I don't know if this is going to work because the Wi-Fi in the hotel wasn't working very well, so the assistant was just flaking out. So it could not connect. I tested these. No, it was good. I was connected. I just did it. Oh my God, computers are the worst. Never work with computers. Well, at least it proves that the full line code completion wasn't dialing out to the internet. I've got to say, so that, to be honest, the summary part of this is using AI is slower than just learning your IDE and just doing it yourself, because it just doesn't do what you want it to do. Right, let's see if this works. So this is the existing test class that already existed. It's trying to generate some new test cases, which it's doing down here. Okay, that's cool. It's done 2 test cases. Should correctly map message to moods in CSV format. Should return empty string when no mood detected in the message. That's actually not terrible. Every time I do this, it gets a little bit better. That's not what I want. What I do want to do is I want to say, can you please add a test for Haku? I don't want to spend too long on this because I've got 122 slides to get through, but and it did, and that works. Okay. And then can you add one for sad, please? Can you add one for sad, please? Because I do not want the robots to kill me. Also, I'll tell you why I actually use please and thank you, because otherwise you get into the habit of not saying please and thank you to real people. So I teach it to my kids. They say please and thank you to Alexa all the time because otherwise they forget to say it to real human beings. Okay, so now I've got a whole bunch of tests. They seem kind of fine. What I want to do is I say, I'm going to put the cursor in there because apparently it doesn't do that by default. Can you please use parameterized tests? And it should rewrite it into some sort of format which is parameterized. But as someone pointed out, it's not really that fast. And if you're used to using the refactoring tools in something like IntelliJ IDEA, you might be faster doing this manually. It's quite good for things like huge generation of stuff so that you don't have to do a whole bunch of things. Has it used parameterized tests? No. Okay. No code generated. Okay. So thank you. It has completely proved my point that, there's a lot of work to be done in this area. Okay. Let me just quickly unmirror my screen and see if I can get this to work. Wow, that was fairly painless, wasn't it? So, AI will make you super productive. It is good for generating mundane and predictable code. So it's really good for all your boilerplate stuff. It's great for that kind of thing. It's also really good for test data, because if there's a definition of mundane in testing, it's data. So it's a really good way to generate loads and loads of data, and you don't have to anonymize production data and stuff like that. It's really good at considering edge cases that we haven't necessarily thought of as well. So it quite often generates tests where I'm like, oh, I'm kind of surprised I didn't have a test case which has got one of these and one of these with one of these. So it's quite good for working together with in order to come up with good tests. So it's a decent pair. It's like pairing with a decent junior to mid-level, I would say. It does not replace you, not by any means. Because the difficult bit in writing tests, as you all know, is not the boilerplate code or the generation. It's all the thinking about, is this really what I want the test to be? Is this really the expected behavior of the application? Is this not just some emergent behavior, or is it really tightly coupled to the code? Because the AI is going to be really good at looking at what the code does and then perhaps tightly coupling the unit test to that. So it's really important that we step back and have a look at the generated code and decide, is this really what I want for my test? Also, AI lies to you all the time. So I was using it for generating some quotes or coming up with, well, actually generating is the right word, for giving me some quotes for this presentation. And I asked, when did these famous authors say this thing? And ChatGPT was like, oh, no, they never said that. I just thought that it was a good quote. So so AI lies to you all the time. So do take everything it says with a grain of salt and check its work thoroughly. When I used to work with Dave Farley, what he used to say, particularly when talking about pair programming, is the keyboard is not the bottleneck. It's not the typing that slows us down. So with pair programming, people, businesses always say, well, there's 2 developers and 1 keyboard. How can they possibly crank out enough code? And the answer is because we don't crank out code. That's not what we do. Developers these days are still producing on average around about 13 lines of code a day on average throughout the year. That's how much code we produce, because it's not the typing which slows us down. It's all of the thinking about what to type and how to type it and the best way to type it into the application that already exists. I stumbled across this article this week, which was about the myths of generative AI, which I think is quite useful given that a lot of the talks today are going to be on AI. There's a number of different myths. One of them is the productivity myth. The productivity myth suggests that anything we spend time on is up for automation. The importance of value of thinking about our work and why we do it is waved away as a distraction. The goal of writing is filling a page rather than the process of thought that a completed page represents. This is what you need to be thinking about when it comes to your productivity. Your productivity is not based on creating lines of code. We all know lines of code is a terrible metric for productivity because it's not about the typing. It's not about the code. It's about what is it the business really needs? How do I achieve that? Is it really the right thing to do? How does that fit with the existing architecture? And how do I make sure I don't break something else while I do that? That thinking takes time. That's the thing that slows us down when we write tests. So if the thinking is the difficult bit, how can we get better at this? And one of the ways that's suggested by Lisa Crispin and Janet Gregory in their Agile testing book is to bring a friend. So they say, we recommend that developers who are good at writing efficient, maintainable code work together with the testers who are good at specifying test cases to automate the tests. I did this when I worked with Dave Farley at LMAX. We did a bunch of testing, not every day, a bunch of pair programming with the testers. And they would help us think about edge cases and unhappy paths and stuff that we just weren't good at thinking about. So it's quite important to work with someone else with a different mindset to help come up with those quality tests. And this reminded me of something I read in organizational physics. Organizational physics talks about sort of 4 different personality types. It's sort of a Myers-Briggs thing, not really. At least in organizational physics, we can move around this matrix. We don't live forever in one. But the idea is there's different kind of personality types. When it comes to testing, we have the stabilizer, who works at a slower pace with a structured approach. And you can see it specifically talks about quality control as fitting in that area. Now, for us as developers, I think we generally tend to be in one of these 2 quadrants here. The producer, who works at a faster pace with a short view, this is very much me, the next thing, the next thing, the next thing. Or the innovator, who works at a fast pace but with a long view and is more sort of creative. So when we're writing automated tests, we need to not be here, we need to be here. And if that means either taking a mindset shift or bringing someone who can help us get there, then that's kind of where we need to be when we're writing tests. This is the mindset we need to be in. There's a quote from an American poet, which is, creativity is a wild mind and a disciplined eye. And I feel like this applies really well to programming. Of course, we need to be creative. And of course, we need to have out there ideas. That's how we solve business problems that haven't been solved before. But it's no good if we don't have the disciplined eye to actually implement it and do a good job. We can't be losing people's money or annoying people with bad solutions. We need both of these things to be effective at our job, which means we need to write tests. So we need to invest the time in writing tests in order to save time troubleshooting them. This is my last thought around writing tests. Because next, we're going to talk about how troubleshooting tests takes time. However, we will slightly circle back to writing tests. When a test fails, particularly if it's an environment like CI, usually the first thought that comes to me when something fails is, what on earth is this test and why isn't it passing anymore? This screenshot shows 2 of my favorite anti-patterns. Favorite is the wrong word. Anti-patterns around testing. 1, a test name that starts with the word test. Test increment. Okay. Test it does increment. Test it doesn't increment. Test it increments by so much. Test something happens when the increment doesn't happen. Like, what does it mean? What is it testing? Probably, in my experience, tests like this test all of those things in one test method, which is not good. And the other favorite anti-pattern of mine is assert true. Assert true, I hate assert true or assert false. Because when assert true fails, it goes, I thought it was going to be true, but it was false. And you're like, what did you think was going to be true, and why is it false? And there's no useful error message there whatsoever. So when this test fails, I have no freaking clue what it thought it was doing and why it's not doing it now. So when you write your test, you have to think about what it looks like when it fails. Your test needs to tell you what is expected and why, so you understand what to do when it fails. A test really only has value when it fails. You don't have to think about it. It shouldn't be thinking about, I wrote this test so it goes green all the time. I can write you a test which will go green all the time. That's not a problem. What I want is a test which will fail under the right circumstances and tell me why it's failing and what to do about it. So I prefer my tests to have things like assert equals, so I can see more clearly what my expectations are and why they weren't met. I do like my tests to start with should. I know there's different patterns for doing testing, but I like should because should gives you a thought of, should it really do this under these circumstances? I also feel like it tends to lead you in the direction of testing one thing. Should do a thing when another thing happens, and that's it. So yes, so assert equals and should. I also like given, when, and then, as you saw in my template. So given, when, and then really gives us a thought of which bit of this test was set up, which bit is doing the actual testing, and which bit is the assertions. I like Spock for this because Spock forces you to do given, when, and then, but you can do it in comments just as easily. It's a bit clunky, but it really helps the reasoning around the text. I also like display name. Display name is great because you can write like full sentences. So again, when it fails, you can see why it failed. And I like assert all. So in the olden days of JUnit, actually currently in JUnit as well, the first assertion that fails will break the whole test and kick the test out. It's not unusual to have more than one assertion, and it's fine, I think, to have more than one assertion to go, I've got one of these, one of these, one of these, it's not null, it doesn't have this, and it looks like this. That's fine. What you don't want to do is when that test fails, fix this line, rerun the test. Fix this line, rerun the test. Fix this line. No, you want it to tell you these 5 assertions failed and these ones passed. So you use assert all for that so that it runs all of them and tells you which ones failed. So these are the kind of patterns which make it a little bit easier to understand what's happening with your test when it fails. So let's talk a bit about why tests fail. I really do need some water, sorry. The kids went back to school last week, so of course I'm fighting a cold off and everyone's full of germs, so don't come near me, full of germs. Also, I did want to show Barbie touring way more times. And I spill water down myself. Okay, let's talk then about why tests fail. I first gave this presentation about a year ago, and I've been working on a training course about troubleshooting tests and why they fail for about the last 6 months. So I've been thinking about this problem a lot. My initial thought was, when we're talking about troubleshooting tests, I kind of want to help people figure out if the code is wrong or if the test is wrong. That's generally how I was thinking about stuff when something fails. Did the production code do something wrong, or is the test now no longer valid? But it turns out that that is, of course, an overly simplistic view of the world. And so really what caused a test to start failing is that something changed, something anywhere. We're talking particularly about tests in CI. Obviously, if you're running tests locally, you probably know what caused the failure. But in CI, something changed. And it's not necessarily your production code or your test code. It might be obviously refactoring or structural changes, or it might be the data changed, or it might be the infrastructure changed underneath you and you didn't know about it, or it might be load or usage. This is kind of one of the things that quite often just gets missed. Tests can start failing because you're running way more tests or you're running way more fake users through the system, and things start to time out or things start to bottleneck. And these are things which are nothing to do with code changes. So when you're looking for whatever changed, it's not just about looking for the Git commit it stopped working on. It's also looking at what else changed in that area when those tests started to fail. So what you really care about is whose fault is it? It's not really, don't tell your boss that. Really what you're doing is you're doing triage. You're trying to figure out if it's your fault or not, basically. So when we've got these things to look at, the first 3, as a developer, the first 3 are probably my fault. I probably changed something. I probably broke something. I probably need to fix that. If it's the data, it might be your fault. The data might be wrong. You might have made a change which broke something. It might be that the production data has changed and moved on, and either your tests need updating or the test code needs changing. I mean, this is something that may be something that you're responsible for. If it's infrastructure, load or usage, it's probably not your fault as a developer. However, that doesn't mean that you can just ignore failing tests because somebody needs to do something about it. But it just means that you need to tell someone else about this. Look, these tests started failing and it looks like we changed from using Mac agents to using Windows agents or whatever it is. You need to tell someone and escalate that so someone else can fix those problems. You need to identify them before you can do that. So in order to do that, you need data. You need data on what's happening with your tests. This is from Develocity. Oh, I don't have a Develocity thing. But the idea is you want to be able to track those tests over time and see if when it starts failing. I mean, CI will do that. You can see that in CI, no problem. You also want to be able to see things like, okay, so these tests fail under these circumstances. What is it? In this case, actually, because it's calling a slightly different build command. So you need the data of what build command was called. You also need to know what infrastructure was running and which switches were used and all the things which go into running that test. Not just which Git commit was it. You need to know everything around that. This is from Gradle's BuildScan. BuildScan is free for Gradle, Maven, and SBT. So you can run your builds with the BuildScan and it will give you all that information for free. So you want something like this, gathering all the information on all the tests wherever they run, so you can actually figure out what on earth is going wrong with them. Now you know whether it's your fault or not. Presumably, if it's your fault, next step is to fix it. Easy. Job done. End of presentation. No. I love this quote from Ada Lovelace. Your best and wisest refuge from all your troubles is in your sides. I was trying to think of a scientific approach to fixing tests. I was trying to think what my approach to fixing testing is. I think it's like a lot of other developers, like poke at it until it starts working again, or poke at it until you've made changes to so many files you don't know what you did and when, and now everything's broken and I have to revert everything. So I was trying to think about a slightly more scientific idea of troubleshooting these problems. So everything is iterative and cyclical these days, so I drew a little circle. The first thing you need to do is obviously investigate what the cause of the problem is. What went into that failure? So we've already talked a bit about that. This is about data. This is about what circumstances was the test running under. We want to see things like, was it running locally or CI? This is another build scan. It's got some really nice tags that shows you which version of Java it's using, which operating system it's using, which tests failed and so forth. So that's quite a good way of figuring out what were the things which went into that build and that test before it started failing. And I can show you some more tools for investigating the failures too. Sorry, yeah. I think this is the last demo. I thought the last one was the last demo, but there you go. I know. Mirror. So in IntelliJ IDEA, you've got a function called analyze stack trace. So if you have a stack trace on the clipboard, which I do, you can paste it into here. Well, it automatically pulls it off the clipboard. You can say, okay. Oh, that's not right. Hold on. Analyze stack trace. That is a built-in. Here is my stack trace. So if you've got a stack trace from your CI environment, from a production log, from somewhere else, you can paste it into IntelliJ and open it in here, and it will give you the ability to sort of navigate through that stack trace like a real stack trace. And you can also, you want to combine that with something like the build scan or wherever, so that you can get the Git commit, so that you can get to, obviously you need the same version of the code that was running the thing that caused the error. Otherwise you can't reproduce it. And if I have not tried this demo before, so let's see if it works. Well, that's not going to work because it's not the right project. But you can also paste the Git hash in there and you go to the right commit, so you check it out, so forth. I know most people know how to use Git. I don't know how to use it very well from the command line, so I like to use it from inside the IDE. Okay, stop. How are we doing for time? Cool. All right. So you can use tools for investigating more. There's also one of the tools I really like and have used quite effectively is the remote debugger. So you can attach your debugger to a remote server to figure out what on earth is going on in there. It can be kind of complicated and difficult. But if you are interested, there's some documentation on IntelliJ's website on how to do that. So once you've done some investigation, you should be able to reproduce it, because really the last thing you want to be doing is remote debugging, because remote debugging is a pain in the neck. You don't always have access to that machine running those tests at that time. You want to be able to reproduce it locally so you can figure out what on earth is going on. Of course, this is a kind of cyclical thing because, you try and reproduce it, you can't reproduce it, you need to investigate it. So there's going to be some sort of tight cycles around here. But this is where automation is so important, because if your tests are really fully automated, then you don't necessarily have to be downloading a new version of the database and be setting up new network channels to emulate this and all the rest of it. Because if you've got it all, I'm talking about end-to-end and integration tests here. Obviously, unit tests, in theory, you don't need any of that. But if you're talking about integration tests, you want to have them as automated as possible. So when you press go, it gets everything, whether you're using test containers or whatever. So automation makes reproducing the problem so much easier. Next, you want to make changes and run things and hopefully see that you fixed it. Of course, you haven't fixed it because you have to make changes and run it and make changes and run it. But that's this is the ideal spot to be, really. This is the tight feedback loop. This is when you're working locally. This is where you can figure out exactly what's gone wrong. This is where you really need to learn how to use your debugger. Lots of people don't really use the debugger at all. And if we do use it, we tend to use it with breakpoints, and that's pretty much it. But your debugger can do so much more. The debugger's been around for decades, and it does amazing things like conditional breakpoints are really helpful. A conditional breakpoint will just stop at it when a certain condition is there, instead of you having to press next all the time. Go away and have a look at how to use your debugger effectively, because it makes troubleshooting so much easier. And of course, you need to be able to build and run it locally. Otherwise, you can't do any of this stuff. So this is a big important point about troubleshooting tests. So you want to be in this lovely tight feedback loop of figuring out what's gone wrong, making small changes and hopefully fixing it. What you don't want to be is you don't want to be here where you're having to investigate the problem, make some changes, check it into version control, get CI to pick it up, run that test, figure out if it broke. Sometimes that's unavoidable in circumstances like maybe performance tests, which are difficult to reproduce locally, maybe overnight batch stuff, which I really hope you don't have. But this is really, you don't want to be in this loop. This is where it's just going to take days to debug a problem. You want to be down here doing things quickly. So you want to aim for fast feedback and easy reproduction. That's the best way to figure out how to troubleshoot a test. A very wise man, this is my husband, a very wise man said, 99% of the time, the best way to troubleshoot a test is to rewrite it so it's smaller and faster. He does loads of stuff with Android and web-based stuff. So quite a lot of the time, even the tests that he writes first are emulator tests, end-to-end tests, Selenium tests, those kinds of things. And that's really good, for the first few times you're trying to sanity check this website works and it does what it's supposed to do. He's found that every single time one of those tests doesn't do what it's supposed to do, he ends up just taking it apart and writing a whole bunch of unit tests instead, because it's so slow to start the emulator and try and figure out what on earth is going on. And emulator tests quite often test one thing and then another thing and then another thing inside one test, because it's so slow to start the emulator. So his experience is, yes, emulator tests are kind of helpful, but really your tests should be small and fast and easy to reproduce. So now you've fixed your test and everything is fine. It went green. It's always going to be green and it's fantastic. Except in our list of things which impact developers, one of the things was unreliable test results. So what happens when your test goes green and then it goes red and then it goes green, green, red, 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 green, green, red, green. And your test is flaky. Flaky tests drive me insane. Because now we're talking about where you have a suite of automated tests, which you've invested time and energy in, which give you value, which tell you whether the code is working or not, except they don't, because sometimes they go red for no reason whatsoever. And when they start going red, you just ignore them because you're like, well, sometimes it goes green. So it's probably fine, right? But you don't know if the green is the problem or the red is the problem. You don't know if it's really failing or really paxy. So those tests are not really telling you anything, because when they fail, you ignore them. What's worse about that is that because you know you have flaky tests, because you know you have unreliable test results, you start ignoring real failures too. You're like, well, maybe that's flaky too. And so then you just start losing faith in your whole test base. So flaky tests are super poisonous to your productivity and to your trust in these automated tests that you spent time working on. So I have a 3-step process for fixing your flaky tests. The first step seems really obvious, and it's find your flaky tests. And it sounds obvious, but I've been speaking to a lot of developers lately about flaky tests because it's my pet peeve topic. And so I ask people, do you have flaky tests? And people either say no, in which case they're wrong. They just don't know they have flaky tests. Or they say yes, but I don't know which tests are flaky, how many I have, or what the problem is. So you need to find out if you have flaky tests and what the problem is. So you need to be able to figure out, so these are all test failures, and the yellow ones are flaky tests. And in Develocity, you can order them by flakiness. So you can figure out, okay, this one actually is intermittently failing. And there's a difference between a failure and an intermittent failure. Develocity does this by using the automatic test retry in Gradle and Maven. So if a test fails, you have to set up your build to do this. If the test fails, it will automatically rerun it, let's say 3 times. And if it passes in one of those times, it flags it as flaky because one time it failed and one time it passed. Now, some people think that this is a fix for flaky tests because it went green at some point, right? So it's green, right? No, all you've done is identified which tests are flaky. So you can figure out whether, you can flag whether the tests are flaky or not. You can actually set it to say whether you're going to fail the build on a flaky test or not, but that's a separate thing. So Develocity uses that to flag a test as flaky. Another thing you can do is you can look at test results across builds. So you can figure out, given the same code with the same tests under the same circumstances in this build, and this build, this one failed and this one passed, it's probably flaky. So you can do cross-build flaky test detection as well. This is a tool called AutoTrish, which really was an automation of me. It was developed about 15 years ago, and they're still using it in the place where they developed this. This is because I used to be the first person in the office in the mornings, and I would look at all the failures on CI overnight, and I'd rerun them to see if they were flaky or really failing, send out an email saying, these are flaky, these are failing. And some kind soul, who's much more technical than me, went, we should automate this. Like, oh, that's a good idea. So they still have this thing, and it looks across the builds and figures out which tests are flaky and can figure out which ones are broken. So now you know which ones are your flaky tests. You can ignore your flaky tests, right? I hope that you know the answer is no. Do not ignore your flaky tests. As I mentioned, your flaky tests are toxic. They are actually getting in the way of your productivity, and they're destroying your faith in your test results. So step 2, I would like step 2 to be fix your flaky tests, but I am a realist and I realize you can't fix all your flaky tests right now. If you stop everything right now, the business is not going to be happy if you stop working on the bugs and features. So quarantine your flaky tests. There's a few different ways of doing this. When I worked at LMAX, we used to have an @ignoreuntil, and you would give it a date, like 2 weeks in the future. And you say, like, ignore this test for the next 2 weeks because I'll definitely fix it and it definitely won't be flaky in 2 weeks' time. And then it would pop up in 2 weeks' time and still be flaky. And you'd be like, oh, yeah, I need to fix that test. Or you can ignore them, disable them with a tag, and then you can search through those when you get around to fixing them. You can run them on a different build, or if you really want to, you can use that retry to kind of say if they're passing, but I wouldn't advise that. So put your flaky tests somewhere else, away from your critical path, so that when they're flaky and when they're failing, they're not reducing your trust in your normal tests, which you need to be able to trust. Step 3, fix your flaky tests. If you add a new test and it's immediately flaky, or if you're working on a test and it becomes flaky, now is the time to fix that test, not later. If that test is flaky, it's not working. It's not done. It's not finished. Okay, rewrite it, fix it, whatever you need to do. Do not introduce a new flaky test into your build. You're just making things way worse for everyone. However, I recognize there are plenty of existing flaky tests already in your build. So what do you do about them? You need to make time to fix those tests. You can fix them when they impact you directly. Let's say you're working on place order and you've got 3 place order tests which are flaky. Now is a really good time to fix those flaky tests, because then you know that your new functionality or your bug fix is working. You can attach them to related functionality. So if you're going to work on related functionality, it's on the backlog. you can also attach specific flaky tests to that to make sure they get fixed. What we do at Gradle is we have flaky test days. So I think it's once a month. We schedule a whole day where the whole team only works on flaky tests. And we have a list of which tests are most flaky. Don't work on technical debt. They don't work on features, on bugs, just flaky tests. This way you improve the stability of your test base regularly. You can add flaky tests to your backlog if you have a backlog. You can work on them on 20% time, tech debt time, or cleanup time, which is all code for you'll never get around to doing this stuff. But you should definitely work on them. I want to spend a really quick time just talking about the causes of flakiness, because otherwise I just leave you with this thought of flakiness is bad, I should do something, and I don't really know what to do about it. So on this training course I'm working on at the moment, I've been thinking about causes of flakiness as falling into 5 different categories. The environment, network, and resources, which I think is the one we blame most often, like the environment is overloaded or the database is contended or whatever. Integration quotes, so the database didn't come up fast enough or my external service isn't there. Concurrency, asynchronous programming, and waiting. God, this is the hardest one to do something about. Setup, teardown, and test data, and system behavior. So general pointers, because I don't want to spend too long on this. You don't always get to control those first 2 things. You might need to work with your CI team or whatever to make sure that there's enough stuff provisioned for you, for example. Integration points and concurrency, asynchronous, and waiting. Really, you just don't want those in your tests if you can avoid it at all. They're just going to lead to flakiness. Setup, teardown, and test data. There's known good practices for doing that, so by all means go away and read about those and figure out the best way to do that. The most difficult thing is when your flakiness is in the system behavior. This is when I worked at LMAX, we found one of our causes of flakiness was race condition in the production code. But because we were actually looking at flaky tests and we'd already sort of minimized a lot of these other things, that's when we discovered we had a problem in the production code, which was causing flakiness. And when you're working on a financial exchange system, you don't want race conditions in your production code. So you need to address these things because your problem might be in the real production code. Dave Farley has a really good video on the 5 causes of test intermittency. His 5 are slightly different to mine, but there's some really good guidance in that. Right at the end of this presentation, there will be a link to a page on my website, which has all the resources for all the stuff I've been talking about. I have 10 minutes and I have way more slides to get through. So let's talk quickly, she said, about running tests taking time. Surprisingly, not many developers said that running tests slows them down. Now, maybe this is because they're running individual tests inside their IDE and it's quick. Or maybe it's because they're not running their tests at all. 70% of Maven users said they were skipping their tests on their build. And I'm like, that is one way to speed up your build process. Yes. Not a recommended way. However, they are onto something, which is that the fastest test is a test you don't have to run. So you can use caching for some of this. Build cache, for example. Build caches are really effective for multi-module projects, for mono repos with loads of modules, because it allows you to only build and test the code which has changed. So normally, particularly with Maven projects, normally you can make one change, you have to recompile, rebuild, and retest everything, which is slow. So no wonder Maven users are skipping their tests. But really what you want is, if you only change one module, you only want to test that module. If you change the implementation of one module, you only want to test the bits that depend on that implementation, and so on and so forth. So build caching is a technology which will allow you to reduce the amount of building and testing you need to do. It is available for free in Gradle. It is available, Gradle has a Maven build cache plugin as well, and there is an open source one too. Where it gets really effective is if you've got a remote build cache, because which environment is always building and testing your code? CI. So if CI is always building and running your code and then putting the results of the builds and the tests in the remote cache, then when I'm running my things locally, I can get those results from a remote cache. I don't need to run and build everything locally. Of course, one of the fastest ways to run your tests faster is to parallelize them. So this is Gradle running the Groovy language and build. So you can see it runs everything in parallel. It's going to use as many CPU cores as are available, and that allows us to shrink the overall build and test time. Gradle tends to do that by default. It depends a bit on the number of modules and stuff, but this is a thing. You can also run things in parallel with Maven, which I didn't know until I worked with Gradle, which is weird. But lots of build tools allow you to do this. Of course, you have to think quite carefully about whether your tests are going to start trampling over each other in terms of their data, which is another problem, which maybe I'll talk about in a minute. So you can run tests locally in parallel. Obviously, in CI, I fully expect that you're running stuff in parallel in CI. You've got a whole bunch of different agents doing a whole bunch of different things. The problem with this is that this only applies to CI, so I can't make use of this parallelism locally. It also tends to need manual partitioning to try and figure out how to slice and dice my tests. And the problem with running stuff in parallel locally is I'm constrained by the number of CPU cores that I have. But if you use something like test distribution and you have a test distributor in the middle, and we used to do this at one of the places I worked, we built our own one of those, then whether you run your build locally or in CI, you ask the test distributor to farm out the tests over as many agents as you have available. They can be in the cloud or they can be in the local development machines on the local network, and it'll just farm the tests out to all the different agents. You can go like massively parallel. You can get quite smart with this as well. So what we used to do is we would run the failing tests first so that we could get really fast feedback. And you can do things like run your longest running tests first, and it can intelligently farm out all your tests. So it's quite a good way to really reduce your build time. Generally speaking, if you double the number of agents, you halve the build time. That QR code is a case study of Netflix using their Velocity's test distribution. They got their 1 hour build process down to under 5 minutes by using test distribution. So it can be extremely effective. Of course, we can use AI. Like I said, 2024, everyone's talking about AI. Velocity has a thing called predictive test selection, which is based on something that Meta put in a white paper. So Facebook has this like huge mono repo with like loads of tests. And anytime anyone changes one line of code, they have to rerun all of their tests, and they hated it. So they did some analysis and figured out like, can we do like dependency analysis to figure out which tests I need to run if I make this change? And they found out that generally speaking, if you make some changes, all the tests need to be rerun. So that kind of sucked. So then they used some machine learning to figure out which tests give me the most value to run if I make these changes. So if I change these bits of code, which tests are most likely to effectively fail if I've done something wrong? And so they found, and that's what we've got in Velocity, they found that the machine learning algorithm generally selected about a third of the tests. So you don't need to run 2/3 of your test cases. And we find this with our customers as well. Oh, that's really blurry. The red and orangey yellow bar, I'm colorblind, combined is the normal amount of time it takes to run the test in the build. The blue is the rest of the build. When using predictive test selection, our customers didn't have to run all of these yellow bars. So generally, they can not run 2/3 or half of their tests when they're using predictive test selection. So that gives you a really, and it's tunable. You can either run more tests for more certainty, but takes longer, or fewer tests for faster feedback. You don't run this on your release branches because your release branch, you want to make sure every test gets run, but you run this locally to make sure you haven't done anything stupid. Okay, I'm not going to go over that. What if we just make our tests faster? What if Trisha just talks way faster? What if we just make our tests faster? We don't want to use any of those technologies. We don't want to spend those stinking money on stinking Gradle products. It's stupid. What if we just wrote faster tests? Like any performance problem, focus on the worst performers first. We quite often get caught up in micro-optimization, so let's not do that. Let's just look at our slow tests and fix those. Let's talk about the testing pyramid. Or not, because as Martin Fowler points out, like people get really irate about the names of the tests. They're like, we don't have system tests, we have integration tests. No, we have acceptance tests. And then everyone goes, oh, but actually it's not really a pyramid, it's an ice cream cone or whatever it's these days. So let's forget all those names. Okay, let's not worry about the names of our tests. Let's think about the fact that we want fast tests and we have slow tests. And generally speaking, our fast tests are the isolated tests, our unit tests, including sociable unit tests. And our slow tests are our integrated tests with emulators and front ends and end-to-end modules which need to be brought up. The point about the testing pyramid is we want as many tests as possible down here and as few as possible up there. Ideally none, but we might want some end-to-end tests. So that's the point about the testing pyramid, is to try and get us thinking about how to make our tests as fast as possible. I don't care if they're called unit tests or integration tests or sociable unit tests or whatever. Kelsey Hightower says, once things like databases become a hindrance, optimize the testing loop, mock things out to run things fast. You can run locally and you don't have all the same infra dependencies as someone else. End-to-end tests are really compelling because you can see the whole thing going through the whole system. Of course, it makes sense to test that way. But we don't want all of our tests to be end-to-end tests. It's too slow. We want most of our tests to be unit tests with mocks and stubs. And we can do a few end-to-end tests just to make sure nothing stupid is. You want to look out for expensive setup and teardown because that happens on every single test method. At LMAX, we invented time travel. We stubbed out the system clock and put in, we created a clock service so we could stub it out so that when we're running our tests, instead of having to wait for an hour to do the end of day or whatever, you just use a stub clock to trigger certain events. And that means you don't have to hardly wait for anything. It also means your tests are way less flaky because you're not dependent upon the CPU clock. And write better tests. Just saying that your test code is as important as your production code. Probably more so because it tests your production code. So all the things that matter in production code also matter in your test code. You still need separation of concerns and solid and dry and performance and all of those things you care about in your production code. You need it in your test code as well. There is, by definition, a tension between these ideals. Dave Foley's Modern Software Engineering book talks about this. There are trade-offs for all those choices you make, but you need to consciously make those trade-offs. If you want high-performance tests, you might not want to be doing setup and teardown on every single test method, but then that reduces your isolation. So how do you deal with those different trade-offs? Which pros and cons do you want to accept? And test code also deserves refactoring and deleting. It's okay to delete tests. Angie Jones, who knows a lot about testing, she said, I regularly delete tests that no longer add unique value. I think we're terrified of deleting tests. And yet tests become this enormous weight around the application because these tests break. And I don't know why they broke, but they broke. And I don't want to refactor anything because I'm scared and it doesn't seem to work, but I don't know why. It's okay to delete or rewrite tests in order to keep us lean and agile and moving forwards. In summary, we get there in the end. In summary, automate as much as possible by all means. Testing in particular, the whole point is automation. I really hope we don't do point and click testing of everything anymore. We already automate some tests. We want to automate things like the containers and all the rest of it as well. Also automate code generation. Why not? We can use our tools. We can use our IDEs. We can use GenAI. We can use Develocity. We can use test containers. There's loads of tooling in this space to help us write better, faster, more reliable tests. There is a time investment in writing tests because there should be thinking involved. If you take nothing else away from this presentation, this is the thing I want you to take away. Tests take a long time to write because that's where all the thinking is. You have to pay that thinking time somewhere. You either think about it when you write the production code, or you think about it when you write the test code. If you think about it when you write the test code, you write the test code, writing the production code becomes much easier, and then you have a suite of automated tests as well, which show that you did what you thought you did. Invest time in writing better tests. They are easier to debug, less flaky, and they better document your system's exposure. Which leads me to one last quote from my husband. He's going to be so big-headed that I put him in here twice. I've been talking to him a lot about testing lately because I've been thinking about it for a year. But he was talking to his intern about a new code base that they've just inherited. And he said to his intern, he said it in Spanish, but this is in English. Testing is not only for checking the system does what it's supposed to do, it's for documenting the expected behavior. But he actually amended that. And he said, it's not for checking that the system works. It's for documenting the expected behavior of the system. This is what automated tests are for. So when they start to fail, you can understand, is the system no longer working the way it's expected? That seems to be a problem. I should do something about that. Okay, as promised, the black QR code is a link to all the resources and everything I've mentioned in the talk. If you're interested in winning my book on IntelliJ IDEA, then that's the purple QR code. Thank you very much.